Hello again, math geniuses. Today we're going to talk about writing things in standard form. Now, this might help you as you get used to the procedures of converting, say, exponents to standard form, because really that's what this is concerning itself with. And if you think about the word standard, standard means normal, usual, common, ordinary. So you're going to take something that looks a little funny and convert it into something that looks normal, like the way you would expect to see it. For example, this number here, 6 to the 4th power, is not a way you would expect to see a number, usually, right? So let me show you what this means. A couple of points of reference first. This 6 right here, I need a pen. I like a better color than that one. Let's use this one. That's a pretty color. Pretty color. Okay, this right here, the 6, is called the base. It's all about that base. This up here in the upstairs department, written usually quite a bit smaller, is the exponent. I'll put EXP for short so I have a little room to work here. The way that you solve this is you take the base and you just simply write it this many times. 1, 2, 3, 4. Then you hang a multiply sign in between each of those numbers. Now let me caution you here, because the common mistake that people tend to make is that they want to call this 6 times 4 and call it 24. No, 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 no. That's wrong. Wrong, wrong, wrong. Don't do it. Don't do it. It's something much bigger. It's bigger than any of us. And it goes like this. 6 times 6 is 36. 36 times 6 is, calculator. Yeah, I know. I use it just to make sure I got the numbers right, and even then I goof it sometimes. So 36 times 6 is 216. So we did 6 times 6 times 6. 216 times 6 is 1,296. So 6 to the 4th in standard form is 1,296. How would you like to take $6 and have it multiply exponentially into $1,296? It would be nice. Similarly, 12 to the 5th power. Same deal. The 12 is the base. The 5 is the exponent. So first we're going to write out the base this many times. 12, 12, 12, 12, 12. Again, this is not 12 times 1, 2, 3, 4, 5. It's not 60. No, don't do that. It's 12 times 12 is 144. 144 times 12 is 1,728. 1728. 1,728 times 12 is 20,736. 20,736 times 12 is, I'm going to put it down here just for space because it's going to be a huge number, 248,832. Now I'll tell you the truth. 6 to the 4th power exponentially in terms of dollars would have been nice. But if somebody gave me $12 and offered to multiply it exponential for me, my feelings wouldn't be hurt too much for too very long. You know what I'm saying? Now this next form of converting exponent form to standard form looks very scary. This does not look like fun at all. But I'm going to let you in on a little secret. The fact is that this type of problem is actually easier to solve than the two that we looked at previously. Because really, you don't do anything but count. If you can count, you've got it. Simple as that. Watch this. Here's what you're going to do. Tell you what you're going to do. You're going to take this 8.3 here, and you're going to rewrite it down below, but without the decimal. Now, it's still there, but it's hiding, okay? Then you see this 10 to the 6th over here? We're going to take this exponent and just add that many zeros after it. 1, 2, 3, 4, 5, 6. That's a 0, not a 6. Good grief, man. 6 zeros, not zeros and a 6. Oh boy, it must be early. I just got my Starbucks. Taking 2 sips of it. Anyway, so now we come back here. Let me change colors just to highlight the point. Let's make it blue. Calming blue. Now we're going to take that decimal, this 3 right here, and what we're going to do is slide it over to the right 6 places. So starting from here, to correspond with this one, 1, 2, 3, 4, 5, 6. Okay, so now what's the number? 1, 2, 3, comma, 1, 2, 3. So the new number is 8,300,000. That's all there is to it. If you can, in this case, count to 6, this is a piece of cake. And they said math was so hard. Ha! I laugh at them. So let me throw you a little curve now. What if we took that very same 8.3 times 10 to the 6th, which you will see this is not uncommon, and we said, okay, smarty pants, write this in standard form. 8.3 times 10 to the negative 6th. Okay, don't go home yet. Don't turn it off. Don't turn this video off yet. I'm not through with you. Here's the deal, guys. You ready? You do the exact same thing, but in the opposite direction. Think about it. This is a number line, and this is 0. If you go in the positive direction, you go to the right, right? If you go in the negative direction, you go to the left. So take that little piece of information and rewrite this 8.3 just like you did before, without the decimal, and then hang 6 zeros in this direction instead. 1, 2, 3, 4, 5, 6. Let me pause for 1 second. Adding 6 zeros, you don't have to put this many zeros. I just know that that's going to be more than I need, so I just put that many until I figure out where the decimal goes. Okay? It's just a little tool kind of thing that I use. All right, now, it says to the negative 6. So if our decimal starts, let me do blue again. Pretty colors. If our decimal is here at 8.3, and we're going to 8.3 times 10 to the negative 6, we're just going to go in the negative direction, 6 places. 1, 2, 3, 4, 5, 6. So 8.3 times 10 to the negative 6 in standard form is point 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. See, 1, 2, 3, 4. Whoops. 1, 2, 3, 4, 5 zeros, and 8, 3. That's it. That's all there is to it. If you have any questions, any comments, feel free to email me at deliomath@gmail.com. Have fun. See you down the road.